When we search for extraterrestrial life, we almost always look towards Mars. We tend to dismiss moons as dead rocks orbiting in a vacuum. This photograph shows the standard expectation. This environment is cold, barren, and heavily cratered by billions of years of impact. But in a scale comparison, Saturn's moon Titan breaks the mold. It dwarfs our own moon, and its diameter is actually larger than the planet Mercury. Beyond its physical dimensions, Titan possesses a suite of planetary characteristics found nowhere else in the satellite world. This photograph captures Titan passing in front of Saturn, wrapped in a dense, opaque atmosphere. No other moon in the solar system possesses one. The chemistry of that haze is 95% nitrogen. That is the same primary gas that makes up the air we breathe on Earth. Because the surface pressure is 1.5 times that of Earth, a human would not need a pressurized suit to walk here. As the graphic shows, a thick polar jacket and an oxygen mask would be enough to survive the pressure. However, beneath those familiar nitrogen clouds, the thermal reality of the surface is intensely hostile. The surface temperature sits at -179 degrees Celsius. In this environment, liquid water behaves like solid bedrock, forming the frozen crust of the moon. Yet across this freezing landscape, active liquid rivers carve through deep valleys and massive oceans ripple in the wind. This diagram shows Titan's active weather system. With water frozen solid, liquid methane and ethane take over. These hydrocarbons evaporate, condense into clouds, and rain back down. This continuous cycle shapes the geography, cutting river networks into the ice and pooling into massive seas. Titan proves that active weather systems do not strictly require water. It demonstrates that a world can function through an entirely different chemical engine. This is the Cassini-Huygens spacecraft before launch. In 2005, this mission moved Titan from a speculative model to a verified physical reality. The Huygens probe detached from the main craft, surviving a plunge through the thick clouds to mark humanity's most distant landing in the outer solar system. This photograph is the direct visual evidence Huygens captured from the surface. The scattered rocks are smoothly rounded, a shape typically produced by liquid erosion. These frames provided the grounded evidence needed to define Titan as a dynamic, geologically active landscape. But the methane surface is only the outer layer. If we drill deep into the hundreds of miles of frozen water ice crust, we find a global subsurface ocean made entirely of liquid water. Scientists estimate this hidden reservoir contains more liquid water than all of Earth's oceans combined. Containing the solar system's largest liquid water reservoir places this methane-shrouded moon at the center of modern astrobiology. This cross-section illustrates Titan's dual nature, an alien methane-based surface and a familiar water-based ocean beneath. Complex organic carbon compounds, called tholins, are constantly produced in the atmosphere. They coat the surface and slowly filter down toward the subsurface layers. This combination of organics and liquid makes Titan a time capsule of what Earth's chemistry looked like 4 billion years ago, just before life began. To investigate these mysteries, NASA is preparing the Dragonfly mission. This rendering shows the Dragonfly vehicle, a nuclear-powered quadcopter drone. It is designed to fly through the dense atmosphere, hopping between multiple sites to sample the chemistry directly. The ultimate goal is to determine if Titan's prebiotic chemistry has already crossed the threshold into microscopic biology. Titan forces us to look past our Earth-centric biases. It proves that the cradle of life might not be a warm planet close to a star, but a freezing moon at the edge of the solar system.